Hello and welcome back. In this video, we're going to go over solving systems of inequalities. Now, the way we're going to solve these is by graphing, because if you remember back when we graphed a normal inequality, or just a plain old inequality, we would have a line. I'll just give you an example. We would have a line dotted or solid, and then part of the answer was the shading. Okay, the shading was part of the answer of that graph. Well, the same thing happens when it comes to inequalities. The lines are important, but the shading is also very important. So whenever you're solving systems of inequalities, typically you're going to solve by graphing. That way you can see where the shading lies. Now, a small note before we get started. The solutions to each inequality is where the shaded region overlaps. Okay, so that is what is important, where the shaded region overlaps. It will include or exclude the solid or dotted lines. Okay, so please make sure you're graphing your lines correctly and make sure your shaded region is clearly marked. Now, as I'm doing this on a video, I have colors at my disposal. If you want to grab colors, that would be a fantastic idea. Otherwise, you need to find some way of showing me which shaded region goes with which line. That way I can see the overlap clearly. All right, let's get started. So this first one, we have y is greater than 5x minus 2. Greater than means we have a dotted line. So I'm going to go ahead and do this. Negative 2 up 5 over 1 over 1 and 1, 2, about right there. So a negative 6. 1, 2, 3, 4. No, negative 7. Okay. So here is my dotted line for that graph. Now we need a shade. So y is greater than the equation, which means my shading is going to be over here. Actually, I'll use a highlighter because I have highlighters. So here is our shaded region. Next, let's graph the next one. So we have y is less than or equal to x plus 2. So I have x plus 2 up here. Less than or equal to means we have a solid line. So up 1 over 1. And here is my blue line. Y is less than. Now remember, the solution is where the two shaded regions overlap. So I don't need to shade everything, I just need to shade the intersection, which means less than the blue, but still in the red shaded area is right there. And this shaded region is my solution. Let's go on to the next one. So we have y is less than x minus 2, which means we have a dotted line. So minus 2, up 1 over 1, up 1 over 1. Oops, dotted line. And then we shade underneath it because it is less than. Our next one is y is greater than x plus 1. Now you might already be able to see where this is going, but I'm going to finish it out so you can actually see it on the graph. So plus 1. Here is my other dotted line. And we know that y is greater than this graph. So the shading goes above the dotted line. Now, if my solution is where the shaded region overlaps, clearly there is no overlap here. Nothing happens. So your answer to this one would be no solution. because there is no place where these graphs overlap in any context. Okay, we got two more. I knew you love fractions, so I added one for you. What I want you to do, try this one out on your own, and then the video will play again and see if you get it right. Okay, so here's the answer. Now on this one, I shaded everything from my blue line so that you could see where the blue exists by itself and then where it overlaps, and that is our solution. So your solution should be in the region that is above both lines over here. And this is how you would write your answer, by the way. It's just the shaded region. Now in your own tests and quizzes, you need to be very, very clear to me where the shaded region is. If you're not using colors, this can quickly become a jumbled mess. So either shade darker, have two different ways of shading, like up and down versus diagonal, something. All right, so last but not least, let's go to this problem over here. Now, as I mentioned in class when we were going over graphing, it is easier to graph when the equation is in slope-intercept. So what I'm going to do for this problem is I'm going to rewrite it that way it is in slope-intercept form. So this one I have y is less than or equal to a negative x plus 1, because I subtracted the x over. I'm going to do the same thing down here. Y is greater than or equal to a negative x minus 2. So we graph this, plus 1, graphing my first equation, down 1 over 1, down 1 over 1. I have a solid line, and my shading, since y is less than the equation, my shading is down below. Then negative 2. And again, a negative 1 slope, so down 1 over 1. This time, y is greater than or equal to. So I have my solid line still. And then I'm going to shade above the whole blue line. Now you should be able to see quite clearly and easily where these two shaded regions overlap. I'm just shading completely above and completely below. That way you get a better idea. But as you can see, the shaded region where both of these overlap is right in here. And that would be our answer, the area in between the two lines. And this is all I have for you guys today, so it's a short video. Please make sure you finish the worksheet. There are a few example or practice problems attached on the website. If you have any questions, write them down, and I will see you next time.